Welcome to Radicals number 2. So today we are going to learn how to add and subtract and multiply radicals together. So adding and subtracting are the same function. When you subtract, you just add the opposite. So adding and subtracting are one and the same, and then multiplying radicals. So last time we learned how to simplify radicals, and now we are going to take that and use it to our advantage to help us to be able to add, subtract, and to multiply. So we are going to start off with adding and subtracting first. Now, if you've had me before, you know that when you add and subtract something, that you can only add or subtract the same things. The exact same things. So you are not allowed to add x squareds and x to the 10th powers because they are not the exact same thing. You can add x squares with other x squareds, or you can add x cubes with other x cubes. So when we add the same things, we're going to get the same things. So when you add and subtract radicals, you can only add, combine, subtract radicals that have the same root. So square roots, cube roots, they have to be the exact same root, the exact same index, and the exact same radicand. So the root, the index needs to be the same. Let me write that, index. And the radicand, that means that the stuff inside of the root has to be the exact same. So let me grab my highlighter. So in number 1, we are adding 2 square roots of 5 and 8 more square roots of 5. So you will see that the root is the same. They're both square roots. And the stuff inside, they're both 5s. So that means that the square root of 5 and the square root of 5 are exactly the same. That means that I can add my coefficients. So if I have 2 of them and I add 8 more of them, I'm going to get 10 of them. Who's them? Square roots of 5. 10 square roots of 5 are my answer. Ladies and gentlemen, please note that when you add the same things, you get the same things. That doesn't transform into a square root of some other number, okay? It doesn't become a 4th root when it was a square root. When you add the same things, you get the same things. Now, can I check this on my calculator? Absolutely, it's just all numbers here. So 2 square root 5 plus 8 more square root of 5 is going to give me 10 square roots of 5. I don't know. 10 square roots of 5. Yep. Decimal approximation is the exact same. So that means that I have added my like terms correctly. All right, number 2. So I have 5 cube roots of 4, subtracting 3 cube roots of 4, adding 8 cube roots of 4. Are all of my things the same things? Cube root of 4, cube root of 4, cube root of 4. Yes, they are. So I am going to take 5 and subtract 3 and then add 8 more. 5 minus 3 is 2 plus 8 more. That means that we're going to have 10 of those things. What are the things? Cubed roots of 4. The final answer, 10 cube roots of 4. Let me test myself. So I've got 5. I'm using the math button. 5 cube roots of 4 minus 3 cubed roots of 4 plus 8 more cubed roots of 4, and that should give me 10 cubed roots of 4. 10 cubed roots of 4 is the exact same decimal. I'm doing this on my calculator. You can very easily do this on Desmos as well and get a decimal approximation there, but you should always be checking your answers. Okay, number 3. I have square root of 6, square root of 6. Are those things the same things? Yes, they are. Here's the question. How many square roots of 6 are right there? There is an invisible 1 square root of 6. And then we're subtracting 8 square roots of 6, which is going to give us negative 7 square roots of 6. Final answer. You can plop it into your calculator or on Desmos to prove it to yourself. All right, number 4. Square root of 3, square root of 3, square root of 3. The things are the same. They're all square root 3s. So that means that I'm going to be able to take 5 and add 8 and then subtract 16. So 5 plus 8 is 13 minus 16. That's going to give me negative 3 of those guys. Who are the guys? Negative 3 square roots of 3. Easy peasy, right? Looking for the same things and then adding them up. All right, let's take it to the next level. So what about when the stuff is different? So the root is going to be the same, but what happens when the stuff is different? So sometimes you are asked to add 2 radicals that have different radicands. That's the stuff. This is not allowed in math. You can't add different things unless you can convert it somehow, simplify it somehow. We can use our brain and our knowledge of mathematics to manipulate numbers to be able to add them together. We first started doing that when we were adding and subtracting fractions. Remember, you can only add or subtract fractions that have the same denominator. And then pretty soon we came across things that had a different denominator. And then we learned how to find a common denominator so that we could force them to be the same so that we could add and subtract. So the thought process here is the same. We are going to simplify to see if you have these same things. The only way that you're going to know is if you simplify. So check it out. See how I have square root 8, square root 2? The square roots are good, but that 8 and 2, man, they have to match if I'm going to add these 2 numbers together. So what I need to do is I need to simplify square root 8. Factor tree. 8 is 2 times 4, and then 4 is 2 times 2. Because this is a square root, which means it has a root of 2, I am going to circle a group of 2. So that means that I have a 2 that pops out, and then that one is left behind. So that means that the square root of 8 is actually 2 square root 2. And then I can bring down the rest of my equation. So I had square root 8 and square root 2. That was a no-go. But now I have square root 2 and square root 2, and those things are the same things. So if I have 2 square roots of 2 and I add 5 more square roots of 2, then I'm going to have 7 square roots of 2. So something that I could not add at the beginning of my problem, I used my tool of simplifying, and it turns out that they were the same things. I just had to force this one to change its look. If you're like, yeah, that seems like voodoo to me, well, I can prove it to you. Square root of 8 plus 5 square root of 2 is that. And then what did we get? 7 square roots of 2. And it's the same decimal. So my answers are the same. Number 6, I'm looking at square root 20 and square root 5. Those two things are definitely not the same things. So I have to try to simplify that one. Factor tree, 4 times 5, and then 2 times 2. So it's a square root, root of 2. That means that I am lumping two things together, and I have a square root of 5 left behind. And then I can take the second part and move it down. So square root of 20 and square root of 5, again, was a no-go, but now that I have simplified, now it's a square root of 5 and a square root of 5, which is perfect. If you have 2 square roots of 5 and you subtract 3 square roots of 5, then that means that you have -1 square roots of 5. Number 7, a square root of 9 and a square root of 16 are not the same things, but do you notice what kind of numbers a square root 9 and a square root of 16 is? They are perfect squares. Guys, what is the square root of 9? That's just 3. And what is the square root of 16? That's just 4. So 2 times, that means that there's multiplication there. 3 times, there's multiplication there. So 2 times 3 is 6. And then 3 times 4 is 12. So now we're looking at 6 minus 12, which is a -6. When you have perfect squares, okay, they just number crunch themselves right out of there. Check it out. 2 square roots of 9 minus 3 square roots of 16, -6. That's exactly what we got. Final answer. All right, last one, I believe, yes, last one for adding. So on this one, I have a cube root and a cube root. So the roots are the same, the stuff is just not the same. So 3 is the prime number. That one's already simplified, but 24, I bet I can do a better job with 24. Let's see, 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. Because it is a root of 3, that means that I am grabbing a group of 3 things. So I've got 3 2s, and then, whoops, sorry, and then I have this 3 left behind. So a cubed root of 3. All right, if I copy down what's in front of it, that's going to be a plus sign. And then I've got -2 cubed root of 3. So cube root of 3 and cube root of 24 were not the same, but after simplifying this guy, check it out. Both of them are cube roots of 3. You just allowed me, actually you didn't allow me because you're not with me, but were you screaming at me, hey, what about that 3? Yeah, totally forgot it. I looked right past it. I was so worried about simplifying that I totally forgot to take a look at that 3. Where's that 3 supposed to be? In front of the simplification. So that means that that 3 needs to go right there with multiplication. So that means that I'm doing -2 cube roots of 3 plus 6 more cube roots of 3, which is going to give me a +4 cube root of 3. And as always, you can check it on Desmos. You can check it on your calculator. All right, so to sum it up, to add or subtract, you must have the same things. That is the golden rule for adding and subtracting. You must have the same things. Multiplying, on the other hand, multiplying is always so much easier than adding because you don't need the same things. You can multiply anything. You can multiply anything. That means that you don't have to convert stuff. You don't have to do the extra step of making sure that they match. So you can multiply anything, but there's a little condition here, so long as the roots are the same. So you can multiply square roots and square roots, and you can multiply 10th roots and 10th roots. So you can multiply anything so long as the roots are the same. And it is super simple. All you're going to do is you are going to multiply your outside numbers with other outside numbers. And then you are going to multiply your inside numbers with other inside numbers. So what is outside stays outside, what is inside stays inside. So believe it or not, I think that multiplying in math is way easier. Dude, I just said that. So much easier than adding or subtracting. It is because we're allowed to multiply any radical so long as the roots are the same. So now we're going to multiply each radical. Be sure to simplify after you finish multiplying. Okie dokie, so I got a square root and a square root. Perfect, we can multiply. So it's going to be the square root of multiply the inside numbers, which is going to be the square root of 50. Yay! Simplify it. 50 is 5 times 20. 20 is 5 times 4. 4 is 2 times 2. So I've got a pair of 5s that's going to come out. And then I have 2 2s left behind. What am I doing? Holy smokes. 50 is 5 times 20. Holy smokes. I have no idea what I'm doing. 5 times 10. I actually know what I'm doing. I just had a brain fart. Let's try this again. So 10 is 5 times 2. All right, cool. Still have my pair of 5s, but I only have this 2 left behind. Final answer, 5 square root 2. Now let me check this because this is our first time multiplying. So square root 5 times square root 10 is that. And what did we say? 5 square root 2 was our final answer, and exact same decimal. So we have multiplied correctly. All right, next one, a square root and a square root. So we are good to multiply. So that's going to be the inside numbers multiplied. 6 times 6 is 36. What do you know about the number 36? It is perfect. What's the square root of 36? Just 6. Check it out. Square root 6 times square root 6 is 6. All right, next one. I've got outside numbers that I'm going to multiply. So 2 times 4, and then square root, cool, I match. And then 5 times 20 inside. So the outside numbers get multiplied outside, and then the inside numbers get multiplied inside. So 2 times 4 is 8 on the outside. 5 times 20 is 100 on the inside. What do we know about 100? 100 is perfect. What's the square root of 100? It's just 10. So 8 times 10, final answer is 80. Let me check that one. So 2 square root of 5 times 4 square root of 20, boom, 80. All right, number 4. I've got a square root and a square root. Can I multiply? Yep. Outside numbers That's just a -4 times a little invisible 1 there. So -4 times 1 is just -4. And then I've got 15 times 3. So that's going to be 15 times 3 is 45. Let's see, simplify it. That's 5 times 9 and then 3 times 3. So I've got a pair of 3s that's going to come out. Be careful here because this 4 negative is out in front. This 3 is going to come out and join it. And then I have this 5 left over. Final answer, -12 times the square root of 5. And again, you can plug that multiplication into Desmos, look at the decimal, plug your final answer into Desmos, and then check the decimal. Those decimals will be the same. All right, number 5. Holy smokes, what happens if you have 3 numbers that are multiplied together? Same stuff, just multiply. It's a square root and a square root and a square root, so we are good on the root part. Now we just need to multiply all the outside numbers. So that's going to be a 2 times a 3 times another 2. And then we're going to multiply the stuff inside. So that's going to be a 6 times an 8 times a 2. So 2 times 3 is 6, and 6 times 2 is 12 on the outside. 6 times 8 times 2, just so I don't make a mistake, that is 96. All right, 96. Well, both of those numbers are divisible by 3. So 3 and 32. 32 is an even. So 32 divided by 2 is 16. 16 is 4 times 4, and 2, 2, 2, and 2. All right, don't forget, 12 is hanging out front. It's a square root, so I'm looking for pairs. So I've got a pair of 2s that comes out. I've got another pair of 2s that come out, and then I have this 3 and this 2 left behind. So a 3 and a 2 left behind is going to be 6. 3 times 2 is 6. So my final answer is going to be 12 times 2 is 24, and 25 times 2 is 48. I think that my pen is dying. 48 times the square root of 6. 48 times the square root of 6. Pen is dead. Okay. I guess I'll have to switch to green instead of teal. If you're like, man, I don't trust myself on that. I had to multiply 3 things. Well, just throw it into your calculator or put it in on Desmos. 2 square root 6 times 3 square root 8 times 2 square root 2. There's my decimal, and then what did I get? 48 square root 6, and that is a perfectly lovely matching decimal. All right, number 6. If you're not pausing me and working ahead, you should definitely be pausing me here and working ahead on this one. Outside, square root, square root, square root. Okay, go. Outside numbers, 4 times 3 times 1. Inside numbers, 5 times a 10 times a 4. So we're going to have 12 on the outside. 50 times 4 is 200. All right, then we simplify. 2 times 100. That's 10 times 10. That's 2 and a 5, 2 and a 5. All right, don't forget, 12 is out here chilling. I've got that pair of 2s. I've got that pair of 5s. And then I have this 2 left behind. So final answer, 5 times 2 is 10. 10 times 12, that's 120 square roots of 2. 120 square roots of 2. If you're not making time to work ahead of me, please make time to do that. I'm not going to just pause on my video and have a bunch of silence waiting for you to work it out. That's got to be on you. You are manning the controls. Hit that pause button, work ahead of me, and then play me and allow me to go ahead and check your work for you. All right, last thing, multiplying with variables. Please remember that you multiply the numbers, but when you multiply variables, the rule is that you add up the exponents, right? If I said x squared times x to the 5th, that would be x times x, and then 1, 2, 3, 4, 5 of those guys, which would be 1, 2, 3, 4, 5, 6, 7 in total. So the rule when you multiply variables is that you add your exponents. So I'm going to multiply. I've got a square root and a square root, so I'm good to go. So multiply the numbers first, and then multiply your variables. So this is going to be 40 x to the 3rd power. So we need to simplify that square root. I know it doesn't say, but in math, we always simplify. It's good practice. Let's see, so 40 is 4 times 10, 2 times 2, and 2 times 5. This is a square root, so I'm grouping up 2's. So I've got a 2, and then a 2 and a 5 left behind, which is going to be square root 10. For the x's, I have x, x, x. I'm grabbing 2 in my group. So that means I'm going to have x, and then I have 1 left behind, so a square root of x. My final answer, the outside numbers are 2 times x, and then my inside numbers are 10 times x. Bad thing about these problems is that you cannot check them on your calculator. You can check your square root of 40 is 2 square root 10. So you can check this number here, but you cannot check it with variables in your answers. You can only check a numerical answer. That means an answer with numbers on the calculator. All right, last one. So a square root and a square root. So we're going to multiply numbers first. 15 times 10, and then n to the 3rd times another n to the 3rd. So that's going to be 150 n raised to the 6th power. And then we're going to simplify. So 150 is 15 times 10, that's 3 times 5, that's 5 times 2. It's a square root, so I want a pair. Who's left behind? A 2 and a 3. 2 times 3 is 6. And then I'm going to do my ends. 1, 2, 3, 4, 5, 6. And I need pairs. So here's a pair of ends, and here's a pair of ends, and here's a pair of ends with no ends left behind. That means that there's nobody left in this square root. So when I put that together, my final answer is going to be 5. That's n to the 3rd power, and the only thing left in the square root is a 6. That's it for today. Adding and subtracting means that you need to find the same roots in order to add or subtract them. And then in multiplying, all you have to do is have the same index, and then you can multiply whatever you want. Multiplying outside numbers together, multiplying inside numbers together. Hope that's good. Let me know if you have questions.